Okay. So finishing up chapter 2. Lots of methods. Get the review sheet. Monday we're reviewing. Question. You get your quiz back on Monday. Got about a fourth of them done. They're not bad. They're really not bad. Here's my issue. Open? No, definitely. But I think so much time is spent trying to find examples in the notes. It's like, it was 6 questions. Yeah, there were 4 bonus, so it was 10 in a half hour's time. So it wasn't enough time. That's because you spent most of the time trying to find it in your notes instead of just doing the problem. The notes are not how you do the problem. The notes are there when you kind of are stuck. And if you're stuck from the very beginning, then you didn't practice. Or your practice methods are not working for you. That's the problem. The notes are there as a backup, not as the primary. Because on your test, you don't get notes. Okay. So and it wasn't as much of an issue Monday, Wednesday, but on Tuesday, Thursday, probably 3/4 to 2/3 of the class were at the deadline. And it was like, they're still here. They're furiously looking through the papers instead of working the problem through. And it's almost like they see the problem and they don't even want to start the problem until they find it in their notes. If you're going to use notes, how about having your notes organized? So you know exactly where it is on like one piece of paper. But those are skills that maybe I'm taking for granted you would come and think about on your own. So I haven't discussed it. So I'm going to try to make sure I do a better job of that, especially with quizzes that we have left. Okay. But for the most part, they haven't been bad. My fault, I made a mistake. At the top on the quizzes, it said 6 points apiece, and it was 48 points, and there's only 6 questions, so that's 36 points. I changed it and made it 8. And again, more points means more partial credit. But to kind of offset that, I made the bonuses worth 5 instead of 3. Not that everybody did the bonuses, but those that did, and a little bit more room to play with. Plus it boosted the total number of the points. So you could max out 68 out of 48. Okay. Test is next Wednesday. Homework is due Wednesday. Your test is next Wednesday. If you still need an assignment sheet, get one before you leave. Make sure, don't leave until you get a review sheet. They're posted today. So it'll be in your email, it'll be on the announcements, but make sure you get a physical copy of it. And that's what we're going over on Monday. Ignore this stuff, that's not you. But you see what Trig has to cover. We got all these formulas, they got these formulas, got those formulas, and 11 more to come. So, and they don't get to use no. On quizzes, yes. Test no. So don't feel bad for you. Feel bad, well, don't feel bad for them either, because you're not. It's that. So far, solve by factor. When the directions say you have to solve it by factor, you got to show those steps for factor. Any other method gets you 0. You'll never see directions say solve using the square root method, because you can't complete the square unless you use the square root method in step 4. There will be a question in your solve it any way you want where you'll have a setup in the square root method. Hopefully you recognize because you've actually done the review sheet and you've listened to these words. Solve by completing the square. That's where we left off, solve by completing the square. Step by step. You have to show the steps for completing the square. If you don't show completing the square work, no credit at all. 0 out of 10. 0 out of 10. You have to show that work for that one problem. and quadratic formula. So there's 3 questions where you have to do it the stated way. After that, solve it any algebraic way you want, as long as you show the appropriate work. And every question it says that right in the directions on the review and on the test. So there's no confusion. So we did this question. I'll back this up now. We did this question before we left using the quadratic or completing the square. And the second step of completing the square after you isolate the constant is you have to make sure it's 1 times x squared. So we had to divide all of the terms by a 4, which isn't bad because 16 reduces to just a 4. But on the right side, when you add 5, you have 5 over 4, and you're working with fractions. So you're going to have to deal with completing the square and you have fractions. I guarantee on your test, when you have to do the mandatory completing the square problem, you will have to deal with fractions. But the bonus completing the square question, yes, you will. That's why it's a bonus. But the fraction stuff, completing square, quadratic formula stuff, as the bonus. I gave you that, that ski level question as your mandatory question. Test question. The higher level ones, bonus question. Are they doable if you follow it step by step? Absolutely. It doesn't change. It's attainable for everybody if you just go step by step. And you're not going to get there unless you practice it the same way every single time. So we're picking up at 62 and 64, which is our quadratic formula. Now here's a question. I don't need you to say yes or no. I'm not trying to, put anybody under the bus. Just think to yourself. Have you printed this yet? Have you actually gone to the trouble of opening this up, saving it, or printing it out so you have all of these steps available to you as you work out your homework? I said this last week. So every single step for first step, try factoring. The next one, here's the steps, step by step for square root method. Step by step for completing the square. The work that I want to see. And then quadratic formula, here it comes. And we're going to do number, I already wrote it down, 62. That out. Step by step. So I'm hoping that's big enough. It is. There was on that. How's it look on the screen? Good. First step, the solution of any, or solutions, might be more than one, of any quadratic equation. Remember, that's an x squared. That may be written in standard form. Ax squared plus bx plus c equals 0. Where a, b, and c are any real number. Provided a does not equal 0. Because if a is 0, 0 times x squared means you don't have an x squared anymore. Then it's just a linear equation. So as long as a isn't 0, we have a quadratic. The answer, this x will equal, the way we read this out loud, the way we pronounce this, it's the opposite of that b. It's the opposite of this coefficient of x. Opposite of b plus or minus the square root. So all of this is underneath the square root of that b value squared minus 4 times this coefficient, this a, times that number, that c, the whole thing over 2 times that coefficient, 2 times A. That's the answer for this. So what you have to do is step by step, identify A, B, and C, plug it in, simplify. But your details are going to matter. Things I'm going to look for are going to matter. Your work has to justify your answer. There are little details that I'm telling you, and so you need to make sure you understand what I'm looking for, that will lose points. Not the whole thing, but little details that I keep talking about, they're going to lose you points. One of the most important details is going to be the word parentheses. The necessary parentheses when they happen. Because if you write something like this, if you write negative 8 squared versus like it's supposed to be negative 8 squared. If you write this and get positive 64, that's wrong. This does not equal positive 64. It's negative 64. This is how you get positive 64. Because this is negative 8 times itself. Positive 64. This is negative 8 times 8. So there's a negative out in front. It's not positive 64. So if you don't put parentheses around it, what's the big deal? Well, it's wrong. That's the big deal. It's not the same thing. I can take off 1 point, or I can take the whole thing off because it's wrong. What you wrote is wrong. What would you like? Oh, like this. So, step by step. Number 1, rewrite the equation in standard form. Standard form. In other words, make one side equal to 0. Undo fractions. This is huge. It's part of step 1. Drives me crazy when all you have to do is multiply by the least common denominator and get rid of fractions. When there's a problem with fractions, and I see people putting fractions into this thing, it makes it really messy. Like, why are you doing fractions inside a radical? That makes a bigger problem for you. If you have fractions, undo fractions, multiply every term by the least common denominator. Okay. The only one where you actually have to deal with fractions would be completing the square. You might have to work with fractions on the bonus. So rewrite, I need to move that up. No. No. This is where I laziness. Please do yourself another huge favor. We'd like ax squared plus bx plus c. It doesn't matter which side x squared is on, but make your x squared positive. Make your x squared positive. Right now, if you, this is going to be what I don't want. 8x equals 4 minus x squared. This is what I see that I don't want. Or in fact, you don't want to. Well, there's only one term here, so I'll make 0 here. So they subtract 8x. And so there's the 0, and they leave it like this. 4 minus 8x minus x squared. And because, it goes in order, ax squared plus bx plus c, and they go ABC, they think A is 4, because that's the first thing, and B is negative 8, which is true, and C is negative x squared. First of all, your A, B's, and C should never have x's in them. They're just the coefficient. Second, if I just think it's a -1, which that's a -1 right there, that's fine. But the problem is, A is the coefficient of your square term. B is the coefficient of your x to the first, and C is the constant. So it's not in the correct order. It should go, x squared should be first, and it's a negative x squared. Then your x to the first minus 8x, and then a positive 4. So now A is -1, B is -8, and C is equal to 4. And then you got to plug the -1 into the quadratic formula. That doesn't work out well for them either. So here's the best advice I can offer you. Don't let A equal a negative. Yeah, it was really simple to just move one term over to the right side. But you're going to do better if you get your x squared, make that a positive term, which means I'm going to make this positive by moving it to the left. And you have to show this work. You can't just go, ta-da. You got to go, all right, I'm going to add x squared to both sides. And I'm going to subtract 4 from both sides. Everything is going to come over here to the left. Doesn't matter what order I put it in. Can I go x squared minus 4 plus 8x? Can I do that? Yes or no? No. We want A times x squared first term. Then B times x. X should be your second term. X to the second, x to the first, and then the constant equals 0. There's an order. So my square term, x squared. 8x, it's a positive, plus 8x. And then a minus 4 equals 0. Put it in standard form. If you want to get it right, you got to put it in the right form, in the correct form. Okay? If you mess up step 1, then we got a problem. Step 1 is done. No fractions to work with. Then make a list. Literally, write down. And don't write it over here on the side. I don't know why people write it on the side. Put it underneath so you can keep track of it better. Okay. Here's what bothers me when I see what I saw in the quiz. There was I don't remember, it might have been 85. I'm just gonna make minus square root -16, and then this one minus this -25 plus I'll just go -4 square root -36. And so I see separation and start working things everywhere. And so 85 minus this is 4i, and then minus, and that's -25 plus 4 times 6i. And then I start to see this 85 minus -25. So all of a sudden, that's not there anymore. And then I have -4i minus 24i. So these are like separate. It's like all over the place. Just keep working from left to right. 85 minus 4i. Minus a positive is now plus 25. Minus a negative is plus. Minus a positive, that's minus 24i. Your like terms, you got 85 and 25, that is 110. You got a -4i, -24i, that's a -28i. Combine your like terms. Because when you work some of it here and some of it here, and then try to put it back together, the back together stuff, people don't get back together very cleanly. There's always baggage left over. They can't get over the baggage. Just like people. So when you make your list, A equals 1. B equals +8. Your signs are going to come with it. C is equal to -4. You need A, B, and C. Every time you do a problem, if you have to know this formula by heart, then you should write it down every time you do the problem. Every time you write it down, maybe you need to say it as you write it, so you're writing it down, doing it, you're seeing it, and you're verbalizing it. So you know it by heart. X is going to equal the opposite of B plus or minus the square root of B to the second minus 4 times A times C. The whole thing divided by 2 times A. Okay. So now. Yeah, he listed them on the side. I don't like that because on the side, you kind of don't see how they come down. Right underneath x squared, there's a right under 8x, right underneath b times x, there's the b constant, there's the c. Then he even says opposite of b. Because when b is a negative, we got to remember to take the opposite of the negative. Substitute. Add the formula, step 3. Substitute the values of A, B, and C. Just substitute exactly what they are. We're going to simplify at the end. Don't try to substitute and simplify all at once. You're going to, something bad's going to happen. It will. No matter how simple the substitution may be, just make sure everything is accounted for. So the opposite of B, so the opposite of A. You don't have to put it in parentheses because it's the opposite of a positive 8. So opposite of 8 plus or minus the square root of B to the second. So a good habit would be right here, because you know you're going to square something, is to put it in a parentheses, so that way you do it with a negative when you absolutely have to have the parentheses. Minus 4 times A, which is a 1, times C, which is negative 4. All of that divided by 2 times A is a 1. I know 2 times 1 is 2, but I'm showing all the substitutions. That way everything is accounted for. A, B, and C have all been plugged in. Not missing anything. So substitute, then you simplify. So negative 8 is just negative 8, plus or minus square root 8 to the second is 64. And then get the sign. It's a negative times a positive times a negative. So we end up multiplying a negative times a negative. This is going to be a positive. Okay. Make sure you have that sign. And then 4 times 4 is 16. Over 2 times 1, which is 2. So we end up with x equals x equals still negative 8. Do not reduce these. We reduce at the end. Negative 8 plus or minus the square root. 64 plus 16 is 80 over 2. And then we have to simplify the radical. If we can break something out, we have to. X is equal to -8 plus or minus. This is 16 times 5, which is 4 times 4 times the 5. So a 4 is going to escape with a 5 left in the square root over 2. So you have to be able to simplify the radicals. You're going to have to, anyway, for the first 4 questions on the test, simplify the radicals. You're going to have to when you do the completing square. You're going to take the square root of both sides. So you have to be able to simplify the radicals. No decimal. Got to be simplified the radical. Now, if I don't go 16 times 5, give me something else besides 16 times 5 for 80. Well, 10 times 8. Well, that would be 5 times 2. From now on, since you know that 8 is 4 times 2, and 4 is 2 times 2, and that's a 2, 8 is 2 to the third. Always. And I think I gave you, I know I'm always so sarcastic about it. Right here, 2 to the second is 4, 2 to the third is 8, 2 to the fourth is 16, 2 to the third is 8. So from now on, when you do an 8, just go like this: 2 times 2 times 2. There's going to be 3 of them, always. Here's a pair of 2s. 1, 2 will escape. Here's another pair of 2s. Another 2 is going to escape, and a 5 left behind in square root jail. You have a 2 times 2 that broke out. That's a 4 square root 5. So however you break apart that 80, you're still going to end up with 4 square root 5, no matter what. You have to simplify. Now, you don't get to just reduce things. You don't get to just cancel things out. You don't get to just cross off the 2, the 8, and the 4. You either simplify and show the factoring, or you split it. You have to show this. We'll do it separately. You either show that you factor it, then you reduce it. So the common factor for an 8, a 4, and a 2 is a 2. So you're going to factor out a 2. And you get 2 times -4 plus or minus 2 square root 5 over this 2. Now you can reduce a 2. You can't until you factor first. So x is equal to -4 plus or minus 2 square root 5. You can leave it like that. Simplify. Or you do the splits. Separate that one fraction into 2 separate fractions and reduce each one separate. This x is equal to -8 over 2 plus or minus 4 square root 5 over 2. Then you reduce this one. -8 divided by 2 is -4 plus or minus 4 square root 5 divided by 2. 2 goes into that 4 2 times. 2 square root 5. If you want to play it safe, separate the fraction, reduce each one. That way you don't have to worry about finding a common factor. And what we're trying to avoid is this. Well, first of all, if you just cross things off right here, that's false. Crossing things off and going, hey, 2 goes into 8 4 times. You know what? You just crossed off the 2. You don't have a 2 left up to go to that 4. You crossed it out. How do you do the other one? Why you can't? But what we're also trying to avoid is if you had 16 plus or minus let's go 12. Square root 3 all over. Let's go with 24. Hey, 16 and 24. So 8 goes into that 2 times, 8 goes into that 3 times, 3 goes into 12 4 times. So you get 2 plus or minus 4 square root 3. That's all. No. The only common factor you have is a 4. Over 4 times 6. So you end up with, actually, yeah, that's it. 4 plus or minus 3 square root 3 over 6. 4, 3, and 6 have nothing in common. But if you split it, 16 over 24 plus or minus 12 square root 3 over 24, then you can reduce each one. 8 times 2 over 8 times 3. This is 2/3, plus or minus. 12 goes into 24 2 times, square root 3 over 2. Split it out. Simplify each one separately. Better chance of not making a mistake. You gotta factor it and then reduce it, or split it and reduce each one. But this is not the answer. They're not the same thing. Step at a time. Rewriting it is the most important piece. Make sure it's equal to 0. X squared should be positive. That'll help out. 64. (64) is 9x squared minus 18x plus 1. Step 1. Put it in standard form. Undo fractions if you have it. We're good. Make a list, A, B, and C. So A is a 9. What does B equal? Good, negative 18. And C is equal to. Write down the formula. X is equal to opposite of B plus or minus square root B to the second, B squared, minus 4 times A times C, all over 2 times A. So that's steps 1, 2, and 3. Same thing every time. Now you do substitution from middle sigma. X equals. So here's where parentheses. The opposite of that B. So it's the opposite negative of a negative 18. So it's got to be in parentheses. The opposite of the B. And plus or minus square root. So again,
we're squaring b, so parentheses negative 18 squared minus 4 times a, which is 9, times c, which is 9. All over 2 times a, so that's 2 times 9.
That's why I don't, even when A is a 1, so down in the denominator, 2 times 1, I write it out 2 times 1. I want to make sure that when A isn't a 1, I'm not just going through the motions and I'm used to putting just 2. I got to remember 2 times whatever A is. So when it's a 1, I write that down. So when I make sure I write it down, what's the matter? Same thing. Motion, motion, motion. Every time, muscle memory. Everything is substituted, everything is in its place. Simplify. X is equal to a positive 18. Negative and a negative make a positive. Plus or minus. Square root. Negative 18 squared. Negative squared is a positive. 18 squared is 324. How is that a check? Always double checking. And then minus 4 times 9 is 36, and then 36 times 9, or 9 times 9 is 81, and 4 times 81 is minus 324. Huh. But you have a calculator, right? 4 times 9 times 9. 324. All over 18. X equals 18 plus or minus. What's 324 minus 324? 0. Okay, good. What's square root of 0?
0.
So this is 18 plus or minus 0 all over 18. So you're not going to go 18 plus 0 over 18, 18 minus 0 over 18. 18 plus 0 is going to be 18. 18 minus 0 is going to be 18. No matter what, this is going to be 18 over 18, no matter what. So what's the answer?
1.
1. It doesn't hurt because I would think 1's simple to plug in. What is 1 to the second? 1. 1. What's 9 times 1? 9. We get 9. What's 18 times 1? So minus 18 and then plus that. 9 minus 18 is negative 9. Negative 9 plus 9, 0. So when you plug in 1, it works. Check your answer if you get the time. You can always punch it up if it's a, if it's an ugly answer, punch it up with a calculator. Second point of it. Man, if it didn't come out to a nice 1, what if it came out to something ugly? Let's back up to the very beginning. If you think before you act, what do you notice? Plan step by step. From the very beginning. Nine, 18, and 9. Have a common factor. They're all divisible by what? 9. 9. These 3 can be factored, we can factor out a 9. Now I'm still going to use quadratic formula, but it's going to be 9 times if I factor out a 9, everything's getting divided by 9. And it's 1x squared minus 2x plus 1. So remember, at the bottom of the box, I'm solving for x's. So this doesn't have an x. I'm only solving this part, the one that has the x.
Now in here, A is a 1. B is equal to a -2. C is equal to a 1. Look at these A, B, and C. 9, -18, 9. But look at this. If I see a common factor, now I'm just plugging in A is 1, B is -2, and C is 1. Smaller numbers, easier to crunch. If it had a common factor. And how will you know? Well, you would look for it. Does it? Yes or no? If it doesn't, then we're stuck with this. If this was a 17 instead of a 18, then yeah, we're stuck. Nothing in common. But when it does, smaller numbers mean simple crunching. Things you have to look for. Okay. 69 through 76, you get to pick 2. And those 3 questions, or those 3 prompts there. What do you notice? Make a plan, step by step. '69 to '76. Solve the equation using any convenient method. On the test, it says, solve the equation using any algebraic method. You must show appropriate work to receive credit. So you look at this one. Maybe that'll factor. Looking pretty good. This one right here. This has an 11x squared, that's a 33x. I see a common factor. 11 and 33 are both divisible by an 11, and you got an x squared and an x. You can factor out an x as well. So, when 70, I'm looking at factoring versus anything else. What do you see at 71, 72? What do you think? Well, 71 to 72, isn't it already a complete square? So square root method. Take the square root of both sides and don't forget your plus and minus. It's perfectly set up to just take square root of both sides. 73 and 74. Maybe that's complete the square or quadratic formula. I don't know. I see a fraction at the beginning though. It looks like it might be set up already for the completing the square method, even though it has fraction. And then because of this 5x squared, I'm thinking quadratic formula on the last 2. Because I certainly don't want completing the square. I would have to divide everybody by 5. I end up with a 3/5 as my b. But I probably wouldn't want to go completing the square there. That's where I'd want to use the quadratic formula, unless it's factor. So when you make your choice of method, think about it before you try it. So out of those 2, or out of that set of problems, give me 2, anything. 73 and number 70. So we'll do 70 first. Since the directions say solid and I'm first going to look for factor. So over here on the left, I'm looking to see if I can factor. 11 and a 33. There's a common factor. Each are divisible by 11. So I'm going to factor the 11 out. X squared and an x. They each have at least one x I can factor. So I'm going to factor an 11x out of that equation, or out of that left side. Which means I'm dividing each term by an 11x to the unit. The first step of factoring is take out the greatest common factor. 11x squared divided by 11x. 11 is reduced, x goes into x squared, leaving x to the first. Plus 33 divided by 11. 11 goes into 33 three times. X divided by x is 1. So this is just 11x times x plus 3. It's done. You can't factor this any further because it's x to the first. The entire goal is to get x to the first so we can just solve. So once you have factored it completely, you let each factor that has an x, because that's what we're solving for. What is x equal? Factors with x's, you let them equal 0. And then you solve them because they're a linear equation. This goes back to section 2.1, 2.2. That's why there's no 2.1, 2.2 questions on the test. Maybe it's bonus. But not as a test question. Because you're going to do them right here. Divide by 11. What is 0 divided by 11? 0. And here you subtract 3. This x is -3. So at the bottom, x is -3 and a 0. Do myself and yourselves a favor, put them in numerical order, smallest to biggest. It helps. Why not? Because that's how numbers be, there's an order to things. That's 7. And 7. X squared minus 2x. Okay. So now we got to pick our method. Well, I see the fraction, so I probably don't want to deal with quadratic formula or factoring. It's not a perfect square and a number, so it's not right now. It's not square root method. Technically, it is set up as completing the square because in step 1 for completing the square, you isolate the constant. And the constant, the -13/4, is isolated. It's over there on the left hand, the right hand side. So it is kind of set up for completing the square. But if you don't want to complete the square, you could always just make one side 0, get rid of fractions, and use the quadratic formula. So right now, I would think you probably would be choosing between completing the square or quadratic formula. So which one are you going to pick? That's where you go. You got to go with your step-by-step process and make a decision which one you're going to choose. And then go. Not stare, go. Quadratic formula, complete the square. Quadratic. So we're going to go quadratic formula. We want to put it in standard form, we want to get rid of fraction. You will be better off undoing the fractions first and then making one side 0. It'll be simpler to move this to the left side if it's not a fraction. Okay. The only denominator is the 4. So the least common denominator is 4. We're going to multiply everything by 4. And everybody gets multiplied by its own 4. 4 here, 4 times this one, and 4 times that. 4x squared minus 8x. This is equal to negative 13. So now you got to put it in standard form. We add 13 to both sides. 4x squared minus 8x plus 13 equals 6. Okay? So if we're going with quadratic form. Now you want to make a list of A, B, and C. What is A? 4. B is? Yeah. 13. Then you write down the formula itself. X is equal to opposite of B. And again, doing this on your homework, you're doing this. Mom will say it to yourself. Opposite of B, plus or minus, not over on the side, not above it, not over here, not way in the corner, but right underneath where the substitution is going to happen right afterward. Opposite of B, plus or minus, square root of B squared minus 4AC. All of that over 2 times the A. And then substitute, then simplify. X is equal to the opposite of B, so the opposite of a negative 8. Plus or minus square root B squared. So we're going to substitute negative 8 and then square it. Minus 4 times A, which is a 4, times C, which is a 13. All over 2 times A, which is a 4. Then you crunch the number. X is equal to the opposite of negative 8 is positive 8. We have a square root, negative 8 to the second, positive 64. Minus 4 times 13. So that's going to be 16 times 13. But actually, I'm going to go 4 times 13 because that is equal to 52. And then 4 times 52 is going to be minus 208. All over 8. Take a look what I have. Negative 8 squared is positive 64. Minus 4 times A, which is 4, times C, which is positive 13. So 64 minus 208. Is that a positive or a negative? So it's going to be inside a negative. That's going to be a negative 144. All over 8. Don't forget, some answers might end up being imaginary. Square root of the negative, imaginary values. All you're doing is identify A, B, and C, plug it into the formula, and then whatever it ends up equaling is what it equals. You crunch the numbers, simplify, and that's what we're doing. X is equal to 8 plus or minus square root of a negative, poke out the I, then simplify the square root of 144. That's a perfect square. What's the square root of 144? 12. It's a 12. So 8 plus or minus 12i all over 8. And like I told you earlier, do the splits because you have to simplify it. So separate this into 8 over 8 plus or minus 12i over 8, buddy. So anal grade is 1. The common factor for 12 and 8. This is 4 times 3 over 4 times 2. The 4 is reduced, we get 3i over 2. So on the test, at the bottom of the box, x equals 1 plus or minus 3i all over 2. Five, 6. Bad. 6. Extra 8. Okay, so right here, your tests. You have 14 test questions at 10 points apiece. You have 6 bonus questions at 5 points apiece. So that's 140 points for the test, 30 points on the bonus, 170 out of 140 is your math. The first 4 questions, section 2.3. Add these radicals together. Simplify first, and then you're going to add them together. Combine like term. Then you're multiplying. Simplify the radicals first, just like before, and then you're going to multiply. On your quiz, these are nice perfect squares. On the test, they're not nice perfect squares. Then you got to square out one of these. And then you gotta rationalize the denominator. On the test, it was just a nice, like a 2i over 4 minus 8i. But on the test, it might still have vitamins. That was a bonus on the quiz. And we do the solid, 2, 4, and 2, 5. The next set, solve by factor. There's 3 examples. You only got to do on your test, there's only 1 problem per factor. 3 completing the square examples. You only have 1 that you have to do on the test. 3 quadratic formula examples. There's only 1 you have to do on the test. And then 14 through 20, solve it any algebraic way. Just make sure you show your work. Okay. So that's where we're at. 20 or 2.5. And then I even put examples of bonus questions here. Remember the second, page 2 is the solution. Everything you need is here. Number 6. 8x to the 4th minus 18x to the 2nd equals 0. When you get to the problems where it says solve it any way you want, try factoring. Okay. For world peace, try factor. For all the dogs and kittens in the world, try factor. Okay. For the sake of your grade, try factor. Because it'll be the quickest, most efficient, simplest, easiest way. If it works, if it factors. If it doesn't work, then use your fallback, quadratic formula or whatever. Quadratic formula doesn't work on an x to the 4th. Anyway, quadratic formula only works on ax squared plus bx plus c equals 0. So I'm looking over here, I'm looking for a common factor. Oh wait, there is a common factor. I can factor a 2 out of each of these two, the 8 and the 18, and they each have an x squared. So I can factor out a 2x squared out of both of these two terms. I factor out the 2x squared, I'm dividing. 8 divided by 2 is 4. X to the 4th divided by x squared is x squared minus. What is 18x squared divided by 2x squared? 9. So that's 9 equals 0. And technically it's factored. Since this is just a square and just a single x squared and a constant, you can do this. You have your 2x squared equals 0. You have 4x squared minus 9 equals 0. Now, if there was an x to the first in here, you would have to factor this apart, but it's a square and a number. Divide by 2, x squared equals 0. Take the square root. X equals, if I go plus or minus 0, should I put plus or minus in my answer? What is plus 0 versus minus 0? Are they the same thing? Yeah. So you wouldn't put plus or minus 0, you just put 0. Here, add 9. 4x squared equals 9 divided by 4. X squared equals 9 over 4. Take the square root. Don't forget your plus and minus. X equals a plus or minus. Remember how we simplify a fraction in a square root. We can separate it into square root 9 over square root 4. Square root of 9 is 3. Square root of 4 down below is 2. Plus or minus 3 over 2. So we have 3 solutions. A negative 3 over 2, a 0, and a positive 3 over 2. That's how you would write it if you separated it. But I'm fine if you just go, hey, we get x equals 0, comma, plus or minus 3 over 2. Don't put, do not put this. 0 plus or minus 3/2. Because now you're saying it's 0 plus this, 0 minus it. It's this answer, and then separate from that is the next answer. 0 plus 3/2 is just 3/2. That's one thing. 0 minus 3/2 is just negative. So there should be a comma separating your. The factor. Understand you can't use the quadratic formula on an x to the 4. Oh, like this one. Can't use the quadratic formula. Which means, I wonder why he gave us one like this. Because I bet he wants us to do the trifactoring part. Yeah, that's what he wants. Yeah, that's what I want. When you see this on your test, I'm really hoping no trifactor. There's no common factor. There's no coefficient in common. This has no x's to get. Like set up parentheses. First times first is x to the 4th. The only way we're going to make x to the 4th, it has to be x squared times x. No other way to make it x to the 4th. It's not going to be x times x to the 3rd. Promise. X squared times x. Your signs. Last times last is a negative. So what will our signs have to be? If this is a negative 36, this sign and this sign, what times what is a negative? It has to be a positive times a negative. So x squared times x squared will make x to the 4th. So I know x squared times x squared, I know that's right. I know these two signs will multiply and make a negative. I know that's right. Now we just got to make 36 that adds up to negative 5x squared in the middle. 36. 1 times 36. 2 times 18. 3 times 12. 4 times 9. 6 times 6. There's lots of ways you can use 36. 5 ways. Which of those have the best chance of making a 5? Positive 4 and negative 9. 5 and a 4. 4 and a 5. 1 and 36 is not going to make a 5. And 2 and 18 won't. 3 and 12 won't. 6 and 6 definitely won't. But a 4 and a 9 has the best chance. Now, here's where you think it through a little bit more. If you want negative 5, which one should be the negative, the 4 or the 9? The 9 should be. That way, I have 9 negatives and 4 positives. 9 negatives and 4 positives would give me 5 negatives. But let's just say we don't even think that through. This will do a 9 and a 4. And we check the middle. Outside times outside, that's negative 4x squared. 9 times x squared, that's positive 9x. That's positive 5x squared, not what I want. I want negative. If I have the right amount, 5, but the wrong sign, switch the signs. That's all you have to do. I have the right amount, just the wrong sign. So now it's factored. And look at the factoring. A square and a number. Let each factor equal 0. This is exactly how it's going to be done on your test. Let x squared minus 9 equal 0. Let x squared plus 4 equal 0. It's ready for the square root method. Got a square and a number. Add 9. X squared equals 9. Take the square root. Don't forget your plus and minus. X is equal to plus or minus 3. Subtract 4. X squared is equal to negative 4. Take the square root. X is equal, don't forget your plus and minus. Square root of the negative, poke out the eye. Square root of 4 is 2. So we have x equals plus or minus a 3, comma, plus or minus a 2y. There's four answers, -3 and +3, -2y and a +2y. Okay. But it factors. You can't do the quadratic formula because it's an x to the 4. (18) 3 square root 6 minus 6 equals 0. Versus number 24. The cube root of 4x minus 3 plus 2 equals 0. All right. This has nothing to do with chapter 2.4 at all, because these are square roots and radicals, solving these kind of equations. Here is what we're after. We want to undo what's being done, and I lost an X. It's not 3 square root 6, it's 3 square root x. That makes more sense. There's no x in that. Okay, this is an x. We're solving for x. We want to know what x is. Undo what's being done to us. If this was just right here, if it was just 3x minus 6 equals 0, you would add 6. 3x equals 6, and then you would divide by 3. Why stop? You want to isolate the radical. You isolate that radical no matter what. So you're going to add 6. We get 3 square root x equals 6. And then you divide by 3. And we get square root x equals 2. It still has a little bit more to go, but you do the same steps. You want to get the radical or the square root of x somehow by itself. We want x. When we ended up with x squared equal to a number, we took the square root of both sides. So if I end up with a square root, and I want to undo that square root, what will I do? Square it, yeah. A square root is going to undo the square. To undo a square root, you square both sides. Square root of x squared is just x. U squared, 4. But you have to get that square root by itself, that radical by itself. Undo a square root by squaring both sides. Now, here's the tricky part about solving square roots and radicals. You have to check your answer in the original question. When we square a radical, it changes the question. We're solving a question that doesn't have a radical. Maybe it will work in that part, but it doesn't work in the original. Because remember, square roots have rules about the domain. You can't take square roots of negatives. So you have to check this in the original, just in case it works another way. So it's 4. What's the square root of 4? What's 3 times 2? And 6 minus 6 equal to 0. So it's good to go. You don't have to write it out. Sometimes you just do it in your head. But check it. If it didn't work, no solution. On number 24, it's a cube root.
Let's see.
Isolate the radical. We're gonna subtract 2 from both sides. This is cube root 4x minus 3 over here, -2. A square root gets undone by squaring. How will we undo a cube root? Cubing it, raising it to the third power. Raise it to the third power. So I raise each side to the third power. The third power of cube root 4x minus 3 is just the 4x minus 3. The cube undoes the cube root. Over here, a negative to an odd is a negative, and 2 to the third is 8. That's -8. That's all. As rated. -8 plus 3 is -5, so 4x equals -5. And then we divide by 4. So x is -5 over 4. You gotta check it. So before the panic sets in, oh, but it's a fraction, I don't want to put that in. Let's take a look. Cube root 4x minus 3, and then a plus 2 is supposed to be 0. That x equal -5 over 4. So cube root 4 times -5 over 4 minus 3 plus 2 is supposed to be 0. So cube root 4 times -5 over 4. The 4 is reduced, so this is just -5 minus 3. So it's the cube root of -8. The cube root of a negative is a negative. The cube root of 8 is a 2. And it works.
Okay. Isolate the radical, undo the radical. If it's a square root, you square both sides. If it's a cube root, you cube both sides. If it was a fourth root, you raise both sides to the fourth power.
Plenty. So we isolate the radical, we're going to subtract 3. Subtract 3 from both sides. And we get the square root of 2x plus 5 equals over here and -3. And because it's a square root, we're going to square both sides. There's a 2x plus 5. Undo the square root, do that. Over there, what's -3 squared? +9. So I get 2x plus 5 equals +9. Subtract 5. We get 2x equals 4. Divide by 2. And we're jumping for joy because we get x equals 2. We write it down and you find out when you get your test back that it's wrong. You just check it. What's 2 times 2? 4. What's 4 plus 5? What's the square root of that? 3. What's 3 plus 3? 6. Does 6 equal 0? No. So I plug in the answer, it doesn't work. Now, here's why. Right here, when you did this, you could have stopped everything and said, wait a second, a square root equals a negative. This thing has no solution. There's no way the square root of whatever this is going to come out as a negative number. Done. So if you actually are paying attention to what you're doing, you can stop 3 steps earlier. If you remember to check your answer, yeah, you'll still get it right because you'll just write no solution because it doesn't work. But look at all the time you say that you're paying attention. I'm not saying one is going to be like that. I'm just saying that's what happens. I have to make a. Okay, so just so you can follow along with what we're talking about. Number 33 is not on the test. I'm not going to do that one. Number 38 here on the review sheet. There is not one like it on the review sheet either. Number 40 looks like number 7 right here, a little bit like 7. So that's a bonus level question. 45. Then you can see right here, number 6, there's a cube root. The number 20 is a square root. And it won't have a no solution, it will have a solution. I don't see one that exactly looks like 45. 47, 47, 51, and 53. They are there. So they are on the review sheet. If you look at the ones with fractions, 18 fraction, 19 fraction. So those are the examples with the fractions. So let's look at 47, 51, or 53. Which of those? 53. 53. One over t squared plus 8 over t plus 15 equals 0. Well, that is not in quadratic. We're supposed to rewrite it so we can put it in quadratic form. Just for the sake of time. Pass those. And the first step is undo the fractions. If I'm going to undo the fractions, I have to multiply this one by at least a t squared to undo this. If I multiply this by t squared, will it undo t to the first? Yes or no? Does t to the first go to t squared even?
Yeah.
Yeah. So the least common denominator is a t squared. So I have to multiply all of these by t squared. And I want to undo the fractions. I want to put it in standard form. Got to make one side 0. So every term is multiplied by t squared. Don't forget the other side, because maybe it won't be a 0. That reduces, it's a 1. Plus, t goes into t squared to get t times 8, so 8t. Plus 15t squared. Equals 0 times t squared is 0. Remember, we want standard form. We would like it to be ax squared plus bx plus c equals 0. We want to go from left to right. The biggest power, x squared, x to the first, then the constant. Right here, because it is on the test, something like this. They don't bother to put it in the right order. They try to figure out what A, B, and C is right now. Rearrange it. 15t squared should go first. Then positive 18. Then you're positive 1. Now make a decision. Factoring, completing the square, quadratic formula. By factoring. If it doesn't work, you'll be done quickly. But if it does work, if it doesn't work, you'll know quickly. If it does work, you'll be done even faster. Because you'll be, the question will be over. No common factor. $15t squared. Well, that's either 1t times 15t or 3t times 5t. You want 8 in the middle. Which of those do you think we should try? 3 and 5, so 3t, 5t. Since these two signs are both positive, these two signs should be two positives. Last times last is a positive, and the middle's a positive. So everything needs to be positive. And hey, happy news. That last term is a 1. What's the only way to make a 1? 1 times 1. So let's see if it works. If it doesn't work, then I'll go quadratic formula. Outside times outside is 3 times t. Inside times inside is positive 5t. And that adds up to 8. Done. That's a lot faster than quadratic formula. If you try factoring. But you gotta have a little bit of, okay, he says try factoring. I don't like that, but I'm gonna try it. You just gotta go for it. But you gotta practice it before next Wednesday. Because once you have a factor, you let each factor 3t plus 1. But that one equals 0 and 5t plus 1. That one equals 0. Subtract 1. 3 times t equals -1 divided by 3. So this t is -1/3. Subtract 1. 5 times t equals -1 divided by 5. And that t is equal to -1/5. So t is equal to a -1/3 and a -1/5. Begins right here, undo the fractions. Put it in standard form. Okay, one side 0, biggest power, smallest power. By factoring, if it does it, quadratic formula or whatever other form you want to use, that's big and square. Okay. The review sheet is exactly like the test, it's just more team questions instead of 1. With plenty of bonus.
So I'll have your quizzes for you on Monday. And have a good weekend.